Hello students, welcome to today's lesson where we are going to look at heat and temperature. We start with the definition of heat, and heat is a form of energy that flows from high temperature to a point of low temperature, which implies that it flows due to temperature differences. So two bodies that are having the same temperature, there will be no heat flow. Then we look at the differences between heat and temperature. One, we have that heat is a form of energy that flows due to temperature differences, while temperature is degree of hotness or coolness of a body in some chosen scale. Then the flow of heat cannot be measured accurately using any instrument, while temperature can be measured using the thermometer. Then the SI unit of heat is joules, while the SI unit of temperature is Kelvin. We move to modes of heat transfer. We have three modes of heat transfer. One, we have conduction, convection, and radiation. We start with conduction. This is where the transfer of heat within a body is done without the movement of the object as a whole. That is, if you are hitting a particle or you are hitting a spoon on one end, that heat is conducted to the other end of the spoon without the particles of the spoon moving. That is where we are saying that there is heat transfer within an object, but that object is not moving as a whole. And this is made possible due to one, vibration of molecules or atoms, then through free electrons. Due to the conduction, we have the classification of materials in terms of conduction. We have what we call good or poor conductors of heat. We start with good conductors. These are materials that allow heat to pass through them. Examples are copper, silver, aluminium, brass, mercury, iron, zinc, tin, and lead, and we have many others. Then we have poor conductors, or what we call insulators. These are the materials that do not allow heat to pass through them. They do not allow heat to pass through them. Examples are wood, air, water, rubber, plastic, and glass. Now in this illustration that we have here, we want to compare the conductivity of wood and iron. So we put them together, and where we have the joint, we wrap using the paper. Then we pass the flame several times, and then we observe what will happen to the paper. We have our observation. The paper gets blackened on the region covering the wood, and this is because wood is a poor conductor of heat, and it did not conduct away heat from the paper, and therefore that heat burnt the paper. While iron is a good conductor of heat, it conducted away heat from the paper, and therefore on that part the paper remained unburnt. Then we have thermal conductivity in liquids. We know that liquids are poor conductors of heat. So in our experiment 1, we want to demonstrate that water is a poor conductor of heat. We have the arrangement here. We have ice that is wrapped with a wire gauze, and this is to make sure that ice remains at the bottom. Then we have water, and then we are heating water at the top. So what are our observation? After some time, we find that water at the top boils, while the ice remained unmelted. This is because water is a poor conductor of heat, so although it is boiling here, it is unable to conduct heat downwards. Then glass is a poor conductor of heat, and that is why test tube is unable to conduct heat to where we have the ice. So we need to note the following. One, the test tube is made up of glass, which is a poor conductor of heat, and this limits the possible conduction of heat down the tube. Then number 2, the ice is wrapped with a wire gauze to ensure that it does not float. Then number 3, the fact that the wire gauze is a good conductor of heat and yet the ice remained unmelted shows that there is very little heat transfer in the water that was unable to melt the ice. Then finally, water is heated at the top, and this eliminates the possibility of heat transfer to the ice by convection. Then we move to experiment 2. In this case, We have two containers that are having mercury and water. Then in between we have the source of heat. The source of heat is connected to our copper rod that is dipped on both liquids. Then on these sides, both sides, we have the asbestos, which are poor conductors of heat. So we are supposed to make our observation. So after some time, we find that the wax coating the beaker containing mercury melted, while that on the beaker containing water did not melt. This shows that mercury is a good conductor of heat, while water is a poor conductor of heat. Now, why liquids are poor conductors of heat? We need to answer that. One, we have that pure liquids have molecules further apart from each other. So although the molecules move about within the liquid, they are slow to pass heat to the other regions because of those distances between the molecules. This is because of large intermolecular distances. Therefore, there is fewer collision between the molecules. We have other liquids that conduct heat. We call them electrolytes. And these are solutions. Like, for example, we have salt solution. These are made better good conductors of heat because when you are making a solution, you are adding two particles, or you are adding particles to a liquid or to a pure liquid, and therefore you increase the compactness of the particles. This reduces intermolecular distances, and therefore it increases the collision between the molecules, and therefore we have that those solutions or those liquids will conduct heat. We have another liquid that conducts heat. We call it mercury. We have seen it in our experiment. This one conducts heat because it is a metal. It is the only metal that is existing as a liquid at room temperature, and therefore it has free electrons. All metals are good conductors of heat. Another liquid that is a poor conductor is bromine. Bromine is non-metallic element, so it lacks free electrons, and therefore it is a poor conductor of heat. From there we move to thermal conductivity in gases. Gases are poor conductors of heat. So we are going to illustrate or to support that using the illustration below here. We have the source of flame here. This is the chimney. We have the region of unburnt gases, and we have hot flame. Then we place the matchstick here where we have unburnt gas region. Now after some times, it is observed that the matchstick held within the unburnt gas does not get ignited because gas is a poor conductor of heat. Then we move to applications of good and poor conductors of heat. One, we have that cooking utensils and boilers are made of metals that are good conductors of heat, while their handles are made of insulators. You find that most handles are made of wood or plastics. Then in modern buildings, you find that we have double walls. Then in between those walls, we have insulators. This ensures that there is minimum heat loss to the atmosphere from the house. Therefore, we are able to maintain a stable temperature inside the house. Then number two, we have that firefighters put on suits that are made of asbestos. These asbestos are poor conductors of heat, and therefore they are safe when they are putting off fire. Then birds flap their wings after getting wet, and as they flap, they introduce air pockets within their feathers, and this ensures that they minimize heat loss from their body because air is a poor conductor of heat. In experiments involving heating liquids, we always place the vessel on a wire gauze because the wire gauze is a good conductor of heat, and it enables uniform spread of heat to a larger area of the vessel. We have the assignment. As you can see, these assignments are coming from the notes or from the video that you have just listened. So make sure that you get everything. So thank you, and let us meet in our next lesson.